Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss a very important topic, mainly how we can easily make the time series chart using Google Earth Engine, mainly Google Earth Engine with Python API. So if you have no knowledge about that this type of Google Earth Engine, or if you have no knowledge about the coding, so that's why I also open an online training program. This registration is the open now. So from this online training program you can easily learn all of things from beginners to advanced level. So you can easily check it all of information from my website, as well as I already added all of those information in the video description. So basically this online training program will be start from the 21st February, and now registration is the opening. And in this online training program mainly focus who don't have any knowledge about the Google Earth Engine, mainly JavaScript and Python API. If we have no knowledge about that Google Earth Engine or Python or JavaScript, don't worry about that. So after completing this full total 7 days online training program, you are able to do any types of remote sensing analysis very quickly and efficiently using the Google Earth Engine, using Python and JavaScript, both of API you can easily use, and further you can easily do different types of GIS and remote sensing analysis. So this registration is the open now, and this class will be start from the 21st February, and you can easily get all of description about this course content for the first day, second day, third day, and all of course content I already added in the video description. So when you join this online training program, you can get some benefits, such as you can get the course e-certificate of submitting all of assignment. You can get all of materials, mainly practice code or PDF reference book, all of things you can easily get, as well as you can get that recorded video class. Okay, and also get the lifetime teaching support. Basically, after completing the total 7 days online training program, if you face any problem regarding any course content, then you can easily get the support, as well as you can also get the research collaboration facility to publishing the scientific paper. So let's go today's session. I try to discuss about that how we can easily make the time series chart using Google Earth Engine Python API. So first of all, we need to import some Python library. So this type of library you can easily import in the Google Colab. Google Colab mainly it's one kind of cloud-based platform. So here already install it all of necessary library. So just we can simply import. Suppose I need the Earth Engine library. I also need import GE map library. I also need to import for calendar library because I want to make the time series chart. This library is also help me, as well as I also import the chart from GE map. I just import the chart. So now in the GE map we can find out lot of chart function. So just I simply import the chart library from GE map packages. So after that just run the code. So in this time it loading. Okay, and this type of packages or library is already installed in the Google Colab. So it is done. So after that we just need to authenticate. Just put here ee dot authenticate with our email address, which email I just use in Google Earth Engine registration. Just I simply select this email I use, just I click and further continue, and then just continue. So now it's successfully authenticate, and after that we just need to connect our cloud project. So for that use here ee dot initialize and mention the project and write the project name. So this is my project name. Just I put and run the code again. So it also there is no problem. So now our environment is ready to use the Google Earth Engine Python API. So now I want to make the time series chart using ready-made dataset. Ready-made dataset mainly this type of data already create the band. So if I show you some data from the data catalog page, So different types of data we can easily find out in the Earth Engine public data catalog. So now from here, suppose I want to work for Modis. So Modis give you a lot of ready-made dataset. So here you can see all of those are ready-made dataset. So ready-made dataset, mainly it provide you the band name, which band you want to work, and we can easily get the information. But sometimes we also need to work with unready-made dataset, mainly raw satellite imagery. Then we need to make some algorithm and also need to calculate different types of equation. Suppose if you, I will show you the one example. Suppose this data, this is the one kind of data visualization indices 16-day global 250 meter resolution. So basically from this data, we can easily access the information, mainly NDVI and EVI. So now in this case, NDVI and EVI, it's ready. Okay, so this band we can easily use. In this case, we are not need to apply any kinds of formula for NDVI. We not need to calculate any kinds of formula for AVI. So we can easily use this type of band and we can easily make the time series chart, as well as we can also display our map. So that's why I said it's one kind of ready-made data set. Okay, so let's go, we try to use this data. So for that, first of all, just copy this snippet id and then just take a variable. Suppose I put the variable name is that NDVI. Okay, and now just put the parenthesis and then paste this image collection id. So after that, I need to filter the specific time period. Just I put here, suppose filter. And how I can filter, I want to filter using date function. So put here ee dot filter dot date and mention the date. Suppose I need the date 2010 1st January from 2020 December 31, or you can put any time period. So in this case, I want to make the time series chart for 10 years data. Just I simply filter my date, and after that we need to select our specific band. So basically this data set provide you the two band. One is the NDVI, then another is the EVI. Suppose I want to work for NDVI, just I copy the band name and further just paste here. So now I simply create a image collection. So then just try to filter for the specific time period and then select for a specific ready-made band I want to calculate for NDVI. So just I make the NDVI, further just run the code. You can see that is, it's okay, there is no problem. And if you check some information, suppose I just call the variable name NDVI and use that suppose size function, size, and now just run the code. So now it computed, we find out it's a number. So just I put here the get info function I just mentioned and further just run the code again. So now we find out that 253 images. Okay, so between this time period 2010 to 2020, we find out that 253 images. Okay, so now I want to use this image collection and make the time series chart. Okay, I want to make the time series chart. So now how I can make the time series chart? So we already use some different types of function. If you check it, I simply search UI dot chart dot image dot series. So here we find out a lot of function for different types of time series analysis. So you can see UI chart image dot series. So it's one kind of function. It's mainly generate a chart from an image collection. So in this case, I have total 253 image collection, and I want to make the time series chart using this function. Okay, this is the function. But in this case, in the Python environment, we cannot use the UI function. Okay, UI function is only work in this code editor, in the JavaScript API code editor. So now how I can work with that? So let's go, we try to do it one by one. So just we need to work with a function. So let's go try to call the chart function from GEmap package. Okay, So now we already create this type of 253 images, and now I want to create the time series chart. So for that, I just take a variable, suppose figure, and just I call the chart chart.image.series. Okay, this function we have to use, and call the image collection. Okay, call the image collection of NDVI. Okay, because NDVI is stored 253 image collection, and if I just run the code, we find out a problem. It show this type of problem you can see. So it show that GEMAP chart has no attribute image. So now how I can solve it? So for that we need to add the function properly. In this time, this function name is that UI mainly chart, then put here the image, and then put here the underscore. Okay, so this is the correct function. Okay, basically this function come from the GEMAP library or packages. Okay, and now if I just run the code again, it show that missing one argument, basically region. It's very important. Okay, for your study area, which is your study area, we need to define it. So we also define the study area. So in this case, how I can define the study area? Okay, so when I use this region, basically your study area, you must need which area you want to work. So now we try to define our study area. Suppose I want to work for my specific asset. So this is the Bangladesh district boundary. So this boundary, it stored total 64 district in Bangladesh. Okay, if you check this attribute table, then you can get the more better idea. So this asset I already uploaded in my Google asset or cloud project asset. I already uploaded this thing, so further I can use it in the Python environment easily. So if you check it, the basically this is my attribute table. In this attribute table, name to column is stored the different district name in Bangladesh. Okay, different district name. So now I want to work with this feature collection, and further I simply choose a one district boundary, and further I want to make the time series chart. So let's go, just copy this feature collection. Just I copy my feature collection from here, and this thing simply just I write the code after the image collection in here, just paste here, and now you just try to filter it. Okay, so let's go, we try to filter, and I just give a variable name. Suppose I put the name is that ROI. Okay, so basically this is my feature collection. It's including total 64 district, but I want to filter it and choose the specific boundary. So just put the filter, and now how I can filter, I define it. Suppose Earth Engine filter dot equal. So now it's arise a question, what's equal what? So I need to just put here the column name. Okay, so if you check what is the column name, so in this case you can easily get this information from your attribute table. Basically from the features we can easily find out the column name, which column is stored all of district name in Bangladesh. We can easily find out from this attribute table. So if you check it from the features tab, it's working. Just I think some networking issue. So in this case, just I directly write the column name. So we can easily find out the column name from our attribute table. So this column mainly stored all of district name in Bangladesh. Okay. So let's go try to write the column name. For my case, column name is that name 2. So when you work your own purpose, you try to check your column name. Which column is stored all of district name. And further just put here the your district name. Suppose I want to make that time series chart for the Dhaka. Just I put here the district name of Dhaka. Okay, so now what happened? So now this ROI, it stored the Dhaka boundary. Okay, so if I just run the code, and further I define the region. So let's go try to define the region in here. Just put here the comma sign, and then put here the region. second argument region equal, put here region mainly your ry, which is stored at the Dhaka city boundary. Okay, so now try to run the code again. Okay, it's working now, I hope. Okay, it's working. And further, I simply call this variable name, basically fig, and run the code. So now the chart will be appeared. We can get this type of time series chart. Okay, so this chart is not look more better. So you can see find out this type of chart, but we can also add some others argument, and further we can easily create the more attractive chart for our research paper or our presentation. Okay, so let's go. I will try to explain all of things how we can easily create the more better chart. So for that we need to add some additional argument for our chart, suppose title. So I take a variable, suppose title, and I put the title, suppose I put the title is that average vegetation index value for Dhaka district. I put this title, look like that. You can put any title for your own chart and define the x level. Okay, mainly horizontal axis x level. I put the x level, basically it show the year. Then we also define the another one, suppose y level, mainly y level, we try to put in here y level. Suppose y level, it show the vegetation index or NDVI value. So just I put here, it's a NDVI, y level show the NDVI, mainly column name. We set the level, and also we define the color. Suppose it default show this type of blue color, but I want to show the color as a any color, you can simply mention. Suppose I put the colors, and I just make the colors, I put the color suppose green. Okay, you can put any color for different chart, we can use the different color. So now this type of additional argument I want to add in my chart. So just I simply put the title, x level, y level, and colors, and these things we can add in our chart option. So let's go. So after the region we need to define the another argument. It's called the reducer. It's very important for reducer. Reducer basically it's one kind of statistical function. So how I can reduce it? Okay, in this case I want to calculate suppose average. Okay, so for that we have to use here e dot reducer dot mean function. Okay, just I put here e reducer dot mean function. Now second argument is very important, scale. Okay, in this time we define the scale as a 250 meter. Okay, it's defined on our satellite image resolution 250 meter pixel. So just keep in here 250 meter. Then we define the x property. X property mainly system time start default we are using here. Then title, I already defined the title and also call this variable name title. You can also just this value you can also directly write in here, but in this case I just take a title variable and then store it my title. So that's why I simply call the title. And x level, y level, same, we try to define in here. X level basically it's come from here, you can see. We define it on the x property, and after that if you want you can also mention the another one, suppose chart type. Okay, you can easily create different types of chart type, suppose bar column chart, line chart, scatter chart. Just define, suppose I put the chart type. Okay, suppose I define the chart type, mainly in here I just put here chart type. I need suppose line chart. Just write here line chart. Okay, after that chart type we can also define. Then x columns we simply put in here. Okay, I just put here suppose x columns. X columns it mainly show the date, so that here the date. And y columns, so just put here the y calls. Y calls it represents suppose the band of NDVI. Okay, After that column name, we simply define the colors. So colors mainly, I already defined the colors as a green color, so you can put any colors. Then after the colors, we need to define here title. So just I define the title. Then we define here, you can see after x level we already defined, you can see x level is the year, y level is that NDVI. Okay, and if you want, you can also mention the legend. Okay, legend location. So for that, just use here the legend location. Suppose legend location. So you can put the right side or top left side, anyone you can put here. Suppose I need these things for the right side, so right here right. Okay, and then close this bracket. So now in this case here, you can see I just simply import some argument. So first one, you can see here, this is my NDVI. Basically this variable stored the image collection 253. Okay, then region, it's my study area. Reducer, I just need the result average. Scale, I define the resolution. X property, system time start. Chart type, I need the line chart. X column, it mainly date. And Y columns, basically it's the NDVI we mentioned in here. Then colors, I already defined the colors, green. And then chart title also. So now run the code and check what happened. So you find a problem, it show that you forget to comma sign. Okay, just put the comma sign. So now run the code. It's working. So now further just print this figure again. So now you can see the chart is look like that. We find out this type of average resolution index for Dhaka district, and we find out this type of chart. Okay, from year of 2010 to 2020. But if you check the value, then we find out this type of value. You can see it show the 2000, 2500. Basically in this case it show this type of value because this data set is not reprojected. Okay, basically if you check this image collection, there also have a scale. So basically this scale we need to use, and further we need to reproject it the pixel value of NDVI. Then we find out that accurate pixel, basically NDVI or EVI, this type of index range will be +1 to -1. But in this case you can see the chart, it show very long value, 6000. Okay, so now how I can reproject it this type of value, I just try to explain about that. So then I hope we can easily do it. So for reprojected, I want to reproject a total to 253 images. Okay, for this NDVI, I need to reproject it. So for reprojecting, when you reproject this type of things, we need to define a function. We need to create a function. Further, this function, we just need to connect with our image collection. So in the Python, when you create a function, we need to use here the def. This is the keyword, and then mention here the function variable name. I put the element name, suppose img. You can put any name as element, and then colon sign. So now we just need to define our argument. My argument is that I want to return this element and multiply with a value, basically which is my scale value 0.001. So this value I need to multiply. Just I put here this value. Okay, so just I define a function and multiply this value, but I want to multiply it all of images. So just I put here the copy properties function, copy properties, and I want to apply these properties all of images, mainly all of element which is available from system time start. So it's one kind of function we created. Okay, so this function, if I just run the code, you can see there is no problem. So this function I need to connect with my image collection. Okay, this function I need to connect with my image collection. Which is my image collection? Image collection will be NDVI. This variable is stored 253 image collection. So I want to connect, apply the scaling function to each images in the collection. So for that, I simply take a variable. Suppose I put the variable name is the scaled NDVI, and then I call this image collection NDVI, because you can see this variable name is the NDVI. So I just call it, and this is my function variable name scaled, and use the map function for connecting. So for the just run the code, it also okay, there is no problem. And now I want to work with this scaled NDVI. Okay, just I copy and then I simply change it. If I just put here the scale NDVI and then further run the code, so now we find out that accurate pixel of NDVI which range belongs with +1 to -1, this range we find out. And if I just run the code again, now if you check it, you can see the 0.6, 0.55, we can find out this type of NDVI chart. Okay, so not only for that, suppose I want to create the chart for EVI. So how I can do that? So very easy. Basically this image collection is already have two band, NDVI and EVI. Suppose just I put here the EVI, enhanced visualization index, and run the code. So now we can easily find out these things also EVI. So okay, run the code. I also run all of those again. So now we try to get the time series chart at the same time EVI and NDVI. So just I simply define the color. Suppose I want to show the EVI as a red color. So just I put here that red and run it. And further, if you check the Y column, basically it represents the NDVI and also EVI. Just I put these things and run the code. So now at the same time, we can generate the two time series chart for our study area in Dhaka district, NDVI and EVI. So now let's print it. So now I can see we find out at the same time NDVI and EVI, and also find this type of things here. You can see the legend. So basically this legend, if you want, you can simply put here different types. Suppose I need this legend in the top side. So just put here at the top and run it. So now this legend will be appeared in the top. So now it show the right side. Okay, after just run the code again. So now I find out the top. You can also put the top left or top right or bottom left, bottom right, anywhere. I use the main plus, simply put in here. So this is the process when you work with time series analysis using Google Earth Engine Python API. So this is the process for ready-made dataset. So now we can easily use it for different temporal. Suppose you need the result for monthly or yearly. Then this 253 image collection, you need to convert into monthly image collection or yearly image collection, and further just apply the same process, then you can easily get this type of things. So after further any other tutorial, I also try to show you all of those step by step, then I hope you can easily get the idea. So you can also display this map. So further another tutorial also discuss about that, how we can easily display the map. So today's session mainly try to focus on the time series chart for ready-made dataset. So now using the same process, any ready-made dataset you can easily do for making the time series chart. Suppose you want to make the time series chart for LST, land surface temperature. Suppose this dataset you want to use and make the time series chart. So you also try this type of data. Further, face any problem, just simply make the comment. And if you want to join my upcoming online training program, which will be start from that 21st February. So basically in this online training program, you will learn all of those things from beginners to advanced level, as well as you also get all of practice code, all of things you can easily access, and also get the lifetime teaching support. So that's why you can easily learn all of details from beginners to advanced level on Google Earth Engine using Python and JavaScript API. So today is no more. Thank you for asking that. Stay happy, stay safe.